So, kinetics, let me continue the yesterday's part. Okay, listen here. See, today I'll start with a question, right? The kinetics part today, I'll start with a question. So, listen carefully. Now, just go through an equation like this. 2a plus b gives rise to 3c. Just assume a chemical reaction 2a plus b gives rise to 3c. If the concentration of A, if the concentration of A is doubled, if the concentration of A is doubled and concentration of B kept as it is, concentration of B kept as it is, then rate becomes twice to its initial rate. Rate becomes twice to its initial rate. Okay. And in another experiment, both the concentration of A and B are doubled. Both concentration of A and B are doubled. Then the rate becomes twice to its initial rate. Twice to its initial rate. Understand? Then order of the reaction will be. See, this is a kind of question which is important in kinetics. So I just given an equation 2a plus b gives rise to 3c. If the concentration of A is doubled and the concentration of B kept as it is, then rate becomes twice to its initial rate. And in another experiment, both concentration of A and B are doubled, then rate becomes twice to its initial rate. Then what is the order of reaction? So let me go through the first part. Concentration of A is doubled, B kept as it is. So concentration doubled, matlab 2 power n, that equal to rate becomes how many times? Twice to its initial rate. So with respect to A, if you want to find order, then 2 power n equal to 2. With respect to A, 2 power n equal to 2. Therefore, n is taken as 1. Order with respect to A is 1. Are you getting it? Next, in second experiment, both concentration of A and B are doubled. Then rate becomes twice of B. In second experiment, both the concentration of A and B are doubled, but rate becomes twice of B. So what does it mean? Already इनका order to find out किया. Now you want to find with respect to B. So with respect to B, 2 power 1. This is with respect to A into 2 power n is equal to 2. Therefore n equal to 0. So order with respect to A is 1, but order with respect to B is 0. Therefore overall order कितना आएगा? Overall order is equal to 1, and rate expression K is equal to concentration of A into concentration of B power 0. Have understand? So I think it may not visible. So may not visible. So overall order is equal to 1. Therefore rate law can be expressed as R equal to K into concentration of A into concentration of B power 0. Is that clear? Why? Because एलोन ए का कॉन्सेंट्रेशन चेंज करने से देयर इज ए एलोन ए का कॉन्सेंट्रेशन चेंज करने से देयर इज ए चेंज इन रेट, बट ये भी दोनों कॉन्सेंट्रेशन चेंज करने से भी फिर वही आ रहा है. सो व्हाट डज इट मीन्स? रेट इज इंडिपेंडेंट ऑफ कॉन्सेंट्रेशन ऑफ बी. So with respect to B, order is 1, with respect to A, order is 0. Sorry, with respect to B, order is 0, and with respect to A, order is 1. So please go through like this. This is a kind of ऐसा models you can do something, right? So 8 times ले सकता है, मतलब इधर concentration is doubled, rate becomes 8 times, नहीं तो 6 times. Like that you can take some questions based on this, right? Next. Now go to one more important important question. If the mechanism of depletion of ozone layer is given like this, see, depletion of ozone layer is given as a, okay, O3 gives rise to O2 plus nascent oxygen. Okay, this is the step 1. And in second case में O3 plus O gives rise to 2O2 gas. Okay, so this is the step 2. So depletion of ozone layer is given like this. The mechanism is given like this. Okay. Now, in the second step, the second step is just given as a slow step or rate determining step. Depletion of ozone layer is described like this. O3 gives rise to O2 plus nascent oxygen, that is the step 1, and it is a reversible reaction. And the second step, O3 plus nascent oxygen gives rise to 2O2, and it is the slow step of the process. Now, what is asking? The overall order of the process is, okay, what is asking? The overall order of the process is, okay. So all of you please listen carefully. See, from the slow step of the process, okay, from the slow step of the process, first we have to take the question from the slow step of the process. Okay. From the slow step of the process, rate R equal to K into concentration of O3 into concentration of nascent oxygen. But nascent oxygen is not the product, na? It is reaction intermediate. Okay. So make it as equation 1. Now just to take the equilibrium process of this ozone decomposition. So Kc is equal to क्या लिख सकता है? Concentration of O2 into concentration of nascent oxygen by concentration of O3. So I want to substitute concentration of nascent oxygen in the first expression. So therefore concentration of nascent oxygen is equal to Kc into concentration of O3 by concentration of O2. So make it as equation 2. Okay. Now substitute equation 2 in equation 1. Substitute equation 2 in equation 1. Then R is equal to K into concentration of O3 into, instead of nascent oxygen write this, मतलब Kc into concentration of O3 by concentration of O2. K is constant, Kc also constant. So R is equal to K into Kc is taken as K dash into concentration of O3 power 2 into concentration of O2 power minus 1. So this is the final expression. Okay. Therefore overall rate, okay, overall rate is equal to 2 minus 1, that equal to 1. So it is a first order reaction. Is that clear? So depletion of ozone layer as per mechanism, the overall order of the reaction is 1. So note down this. Still, so many models are there based on the order. Okay, so but for time being, I just explained two models, and remaining you just try yourself. Okay. Now I am going to the next part, molecularity. You have to listen carefully. See, molecularity. Okay. How do you explain this molecularity? Molecularity क्या होता है? ठीक है? Listen. See, molecularity is defined like this. The number of atoms. Molecularity is defined as the number of atoms, molecules, or ions. The number of atoms, molecules, or ions which are involved in see, wait a minute, the number of atoms, molecules, or ions of reactants. See, the number of atoms, molecules, or ions of reactants which are involved in rate determining step, of a chemical reaction. When I said the number of atoms, molecules, ions of reactants which are involved in rate determining step of a chemical reaction or chemical process is called as molecularity of the reaction. Is called as molecularity of the reaction. Okay? So, like that you can define the molecularity. Is it clear? The number of atoms, molecules, ions of reactants which are involved in rate determining step of a chemical reaction is considered to be molecularity of a reaction. Okay? Now, let me go through important characteristics. First one. Molecularity of a process never equal to 0, fractional value or a negative value. Okay. See, molecularity of a process never equals to 0, fractional values or negative values. Okay. It must be a positive integer. Next, second point. Molecularity of a process is derived from mechanism of the process. See, molecularity of a reaction process means reaction which is derived from its mechanism. Okay. So, mechanism of the process theoretically, so it is a theoretical approach. Okay, it's not any experiment regarding this molecularity. And the third and important point, molecularity beyond 3 is a rare condition. Right? Molecularity beyond 3 is a rare condition. Understand? So this is about molecularity. Okay. The number of atoms, molecules, or ions of reactants which are involved in rate determining step of a chemical reaction is called as molecularity of the reaction. Molecularity of a process never equals to 0, fractional value or a negative value. It must be a positive integer. Molecularity of a process is derived from mechanism of the process theoretically. Molecularity beyond 3 is a rare condition. Okay, so that's it, man. It's about molecularity. Now, coming to the next topic, rate constraint. and what are the factors which influencing the rate constant. So let me go through these points in detail. Okay, so go through the rate constant. It is designated with K, the rate constant which is described with K. Okay, if you see n moles of A gives rise to product, ऐसा एक chemical reaction ले लो, n moles of A gives rise to products. Then rate is proportional to concentration of A power n. Then R equal to rate constant K into concentration of A power n, where K is equal to rate constant. Okay, so the proportionality constant used in rate expression, or rate law is called as a rate constant, okay. Next, see, in the rate expression, the proportionality constant what we are using is called as a rate constant. Okay, it is a specific constant for a reaction at given temperature. So remember this word, it is a specific constant for a reaction at given temperature. It is independent of concentration or partial pressure. It depends only on temperature and sometimes catalyst also. Okay, so you better to go through like this. It is a specific constant. It is a specific constant for a process at given temperature. Next, it is independent of concentration or partial pressure. It depends only on temperature. Okay. Now, let me go through effect of temperature on rate constant. So, I'll have you listen carefully. See, effect of concentration. Wait a minute. Effect of temperature on rate constant. क्योंकि already we described that rate is independent of concentration. Rate constant is independent of concentration or partial pressure. It depends only on effect of temperature. Okay. So it depends only on temperature. That's why we are describing effect of temperature here. Now, listen. आपको ये याद है? For every 10 degrees centigrade rise in temperature, leads to for every 10 degrees centigrade rise in temperature leads to increase of rate constant by twice or thrice. Okay. Known as a temperature coefficient. Understand? For 10 degrees centigrade rise in temperature leads to increase of rate constant by twice or thrice. This is called as a temperature coefficient. So temperature coefficient can be written like this: K T degrees centigrade plus 10 by K at T degrees centigrade is approximately equal to 2 or 3. Okay. So the temperature coefficient of reactions lies between 2 or 3. In between these two, the temperature coefficient will be there. In most of the cases, By 10 degrees centigrade rise in temperature, rate becomes twice. In few reactions, it's a thrice. That's why we are taking 2 or 3 or in between 2 to 3. Okay. So this is about the temperature coefficient. And one more thing. The relation between a rate constant, K and temperature is given by Arrhenius equation. Right? The relation between rate constant K and temperature is explained on the basis of Arrhenius equation. So let me go through that Arrhenius equation once. Okay. So can you remember that Arrhenius equation? K is equal to A into exponential power minus EA by RT, where K is rate constant, A is Arrhenius factor or frequency factor, free exponential factor, and E is EA activation energy. EA is activation energy, R is universal gas constant, and T is temperature. So K is equal to A into exponential power minus EA by RT. Okay, it can be written like this: ln K is equal to ln A minus EA by RT. So if you consider ln K versus 1 by T graph, it's like this. It's a negative slope now. So it's like this, and the slope is about minus EA by R, and intercept is about ln A. Okay. So this is the graph of ln K versus 1 by T. The intercept is ln A and slope is minus EA by R. Okay. And this equation can be written like this also, or log K is equal to log A minus EA by 2.303 into R into 1 by T. Next, if K1 is a rate constant, at T1 and K2 is a rate constant at T2, right? If K1 is a rate constant at T1 and K2 is a rate constant at T2, then log K2 by K1, matlab similar to 2.5 equation. Okay, log K2 by K1 is equal to EA by activation energy of the process by 2.303 into R into 1 by T1 minus 1 by T2. Okay. Now, if T2 is greater than T1, then K2 is greater than K1. Since activation energy is always positive because it is endothermic change. Activation energy is always endothermic change. That's why if K2 greater than K1, if T2 greater than T1, definitely K2 greater than K1. Therefore, as the temperature increases, the rate constant increases. So that's it. It's about Arrhenius equation. Okay. And one more important point here, I'll have you please remember. See, in this particular equation, this Arrhenius equation, K equal to A into exponential power minus EA by RT. If T is infinite, and the temperature is infinite, okay, then K is equal to A. If temperature is infinite, K equal to A. This is the first condition. Another one, if activation energy is equal to 0, then also K is equal to A. So please remember these two conditions. If temperature is taken as infinite, then K equal to A. And if activation energy of the process is 0 also, K is equal to A. Okay? So, this is the effect of temperature on rate constant. Now, effect of catalyst on rate constant. See, listen carefully. Effect of catalyst on rate constant. Effect of catalyst on rate constant T. Okay, how you define this effect of catalyst on rate constant T? Now listen. See, already बोल चुके हम last class में, previous class में I have explained. See, positive catalyst, okay, increases rate, therefore rate constant. Therefore, rate constant also increases. Okay. Are you getting it? Sir, how? Already I told you activation energy must decrease. Say positive catalyst decreases activation energy so that the rate constant will increase. Okay. It can be explained with the help of a graph like this. Okay. So, energy versus reaction coordinate. मतलब catalyst. Reaction coordinate means it's catalyst. Okay. Now, if you follow for an endothermic reaction first. This is energy of reactant. This is energy of product. So energy of product greater than energy of reactant. That means this is endothermic reaction. Okay. This process is endothermic reaction. Now, so the maximum, the height of the graph, this one indicates what? EA, activation energy. Okay. So now this is the activation energy in absence of catalyst. This is the activation energy in absence of catalyst. This process have activation energy this much in absence of catalyst. Again, in presence of catalyst, what happens? Same process we can go through like this. Right? The same process can be given like this. So now this is in presence of catalyst. In presence of catalyst. So what happens now? The catalyst decreases the activation energy. This is the threshold energy at the second point. It is the threshold energy at first. See, in absence of catalyst, threshold energy is maximum. Whereas in presence of catalyst, it decreases. Thereby activation energy decreases. Therefore, rate constant will increase. First rate of reaction increases, thereby rate constant increases. Okay, so this is the working of positive catalyst. Negative catalyst क्या करेगा? Activation energy को बढ़ा देगा. तब rate of reaction decreases, rate constant also decreases. Okay. Similarly, not only for endothermic, you can write the graph for exothermic reaction also. You can write the same graph for exothermic. So, I will go through one more graph, that is for exothermic. Okay. See, positive catalyst, effect of positive catalyst on rate constant for an exothermic reaction. Again, go through the energy versus reaction coordinate graph. Energy versus reaction coordinate graph. Okay, if energy of reactant is less, energy of reactant is greater than energy of product now. So this is the activation energy for forward reaction. Activation energy for forward reaction. Let me make in absence of catalyst. In absence of catalyst. Okay, and here energy of reactant greater than energy of product. Therefore, it is exothermic reaction. It is considered to be exothermic. पहला वाला तो endothermic है, अभी exothermic. वहाँ पे energy of product is greater than energy of reactant. यहाँ पे energy of reactant greater than energy of product. So therefore, some amount of energy is released now. So it is exothermic. Now this is the activation energy graph in presence of catalyst. So in presence of catalyst, the activation energy will be like this. Okay. Understand? Is that clear enough to you? Okay. And one more important point you have to remember. Remember, what is the relation between del H and activation energy of forward, backward? So that point also I'll explain here only. So listen carefully. Okay. So just we rewrite the graph again. Allow me, listen carefully. Now I'm going through the activation energy and del H relation. Del H means enthalpy of the reaction. Okay. Again, energy versus reaction coordinate. Energy versus reaction coordinate. Okay, just to know, just to go through an endothermic reaction like this. This is the endothermic reaction. And this one is activation energy of forward reaction. This one is activation energy of backward reaction, and this is del H. Okay, so this height is the activation energy of forward, and this part is activation energy of backward, and then each other del H. So क्या लिख सकते हैं इक्वेशन यहाँ पे, and the topmost line is threshold energy. Threshold energy. Therefore, activation energy of forward is equal to activation energy of backward plus del H. So please remember like this. Activation energy of forward is equal to activation energy of backward plus del H. Now second में endothermic हो गया ना, exothermic के लिए. So this is energy of reactant and this one is energy of product, and this graph is for exothermic reaction. This is activation energy of forward, and this is activation energy of backward, and this part is del H. Okay, so energy versus reaction coordinate. Energy versus reaction coordinate graph for this is for endothermic and this one is for exothermic, right? Here also you better to use the same equation. Alright, it's just remember a shortest way like this. Okay, both cases you just use the same equation, but del H sine के साथ डाल दो. मतलब activation energy of forward reaction is equal to activation energy of backward plus del H. And for endothermic del H value positive डालिए, for exothermic del H negative sign के साथ डालिए. You just keep the sign of del H here. For exothermic, you just make negative value. For endothermic, you just make a positive value. So that दोनों के लिए एक ही फॉर्मूला से हो जाएगा. Right? So that's it. It's about relation between activation energy of forward, backward, and del H of the reaction. Okay? So rate constant and factors are completed. Now units of rate constant. For a few, this is the last topic for today's class, right? So units of rate constant. How you describe units of rate constant? Units of K. See, remember, units of K depends on order of the reaction. Units of K depends on order of reaction. Okay. Now, for first order reaction, if you see first order reaction, okay. So R is equal to K into concentration of A power 1. So K is equal to R by concentration of A power 1. Just assume A is the concentration term here. R means rate expressed in moles by liter by concentration, rate expressed in क्या नहीं है तो ऐसा लिखेंगे C by T मतलब change in concentration by time. But rate can be expressed as change in concentration by time. Again concentration. ये आसान बनेगा आपको. तो concentration get cancelled 1 by T or time inverse. So time inverse is the unit of rate constant in first order reaction. Next, second order के लिए कैसे लिखते हैं? R is equal to K into concentration of A power 2. Then K is equal to R by concentration of A power 2. So C by T by C square, that equal to 1 by C into T. 1 by C into T. That equal to, अब concentration मतलब moles by liter है, तो it can be written as a liter mole power minus 1 time inverse. Okay, so 1 by C ना, C means mole by liter, so liter ऊपर जाएगा, so liter into mole inverse into time inverse. This is for second order. Next, third order के लिए कैसे find out कर सकते हैं? So third order equations, rate constant का units कैसा रहेगा? So R is equal to K into concentration of A power 3. Then K is equal to R by concentration of A power 3. So C by T by C cube, right? So 1 by T into C square. So that can be written as a liter power 2 mole power minus 2 time inverse. Okay, liter square, क्योंकि मोल बाय लीटर होल स्क्वायर आएगा ना, मोल बाय लीटर, सो लीटर स्क्वायर ऊपर जाएगा, सो लीटर स्क्वायर मोल पावर minus 2 into time inverse. This is for third order. Then what is for nth order? See, कभी-कभी nth order reactions भी वो लोग पूछ सकता है, ठीक है? So अगर if it is nth order, then R is equal to K into concentration of A power n. Then K is equal to R by concentration of A power n. So C by T by C power n. तो 1 by T is 1 by T. C power कितना आएगा? एक C कैंसिल हो गया ना? C power n minus 1. तो मोल by liter whole power n minus 1. So liter power n minus 1 into mole power 1 minus n into time inverse. Okay, understand? So these are the units of rate constant for various order reactions. Okay, so it will be continued in the next class. So I think this information is good for you, like that I am giving. Okay, so just do it properly and do the questions properly. And please, if you like these videos, please kindly like, share and subscribe, and kindly give some valuable comments also. Thank you all.